Hello, this is our voice assistants in Python project demonstration in video format by Max Streeter, myself, Kevin Manello, and Michael Nugan.
Okay, so our project is on voice assistants in Python. Just a basic introduction here. In our presentation, we'll be discussing our project as a whole on building a voice assistant in Python. Our voice assistant is designed to be a helpful tool for anyone looking to simplify their daily tasks. Just tasks like if you're cooking and don't have your hands free, or cleaning, or whatever you're doing, and you don't have free hands and you need to write or type something, this comes in handy. It's a good tool. Um, so, with advancements in machine learning and natural language processing, text to speech and speech to text technology has become more accessible and useful than it ever has been before. Our voice assistant uses state of the art technology to accurately understand voice commands and perform various different actions. So, the goal of our project was to create a reliable and efficient voice assistant that can help users with a wide range of tasks. Throughout our presentation, we'll be highlighting the key features and benefits of our voice assistant, as well as demonstrating how it works and its functionality in real time. So, overview. So, as I mentioned, the use of text to speech and speech to text technology has increased significantly in recent years. This is due to advancements in machine learning and natural language processing, and rather rapid advancements. Speech to text technology offers many advantages over traditional methods of data entry, such as eliminating the need for manual transcription and allowing users to enter data hands free, which is obviously the big one and the obvious one. Speech recognition systems are used in a variety of applications, ranging anywhere from dictation software to virtual assistants. Our proposed project aims to create an AI model that can accurately classify voice data and into predefined questions using various Python libraries and sensors as well. Uh, when we say various Python libraries, we really mean it. We used a bunch of those. Um, and then our AI model will be trained on data created by us as a team, the three of us, Max, Michael, and myself. Um, excuse me. So yeah, the data will be created by us to simulate real-world scenarios, improving its ability to classify voice data accurately. The project's output will be evaluated based on the accuracy and the efficiency of the AI model in classifying the voice data into predefined categories of questions. Contribution. So, our contribution is pretty much this project in general. This is our own project. It's not something that we just found some online and then uh, went from there. It's more something we started from scratch. We didn't really have a template or a guide to do this project. We kind of just started from scratch, like I said. Um, so we did some basic research. That's about it, and then we went from there. Created a GitHub, stuff like that. But so we contribute a whole project to the AI community because of this. As an example of many different libraries in Python coming together to create a simple example of working artificial intelligence. Um, so our project also serves as an example for how to communicate systems with Arduinos to process data. You'll be seeing later we used a little device called an Arduino to process data. And lastly, our project has the potential to make significant contributions to the disabled community as well. So this is kind of a different side or aspect of the project as well. Uh, People who can have difficulty typing or using a mouse or a computer, they may find a product like this a lot more useful than, let's say, people who don't struggle with that kind of stuff.
So, our model uses the Rutter's dataset from Keras to assign numbers to a large set of words. So by assigning numbers to words, we effectively create an identifying system that our model can utilize better. When coming up with data that we wanted the model to classify, we create around 3 to 4 sentences in list form and add those sentences to our trained data. So we can see here that even though the Rutter's dataset contains a lot of word number associations, still we had things like subtract, subtraction, multiplication that we had to assign our own values for because they weren't in the data set already. So we create around 3 to 4 sentences in list form, and then the training labels down here are continuous, where each unique value is the correct answer for that training sentence. So for example, we could see what's the temperature all the way at the top of our train temp data set is assigned a value of 0, which corresponds to a temperature question. And how humid is it, the third example in the train data set, is assigned a value of 1 in the train temp labels. 1 is the value for a humidity question. So first the sentences are converted to their appropriate number form, and then that number list is compared to a long array of zeros. Each number in the sentence is used to find that index in the array of zeros, and then that index is converted to a 1 for each number, effectively creating a large span of indexes where if the number exists within the sentence, it's a 1 at that index, and this is easier for the model to read and correctly classify. The model that we use is a simple sequential Keras model with 2 dense layers. We have a first layer that has we have a first layer with 32 activation ReLU function nodes, and then we have a second layer with 11 softmax activation function nodes. Each of the nodes in the softmax function is giving a percentage to what it thinks the model, or what it thinks the sentence that it's given is classified into. There's 11 because the model or the code is set up to classify into 11 different types of questions. So we have one type for temperature, and another for humidity, and another for doing multiplication and addition and subtraction and division, various things for pulling up weather information in different areas, and all of these different things that we have it do comes out to exactly 11 things that it could classify into. So that's the reason for having 11 softmax functions. And then we use an RMS prop for our optimizer, and for our loss we use a sparse categorical cross entropy function, and our metrics are based on the accuracy of our classifying. So the code is set up to do about 300 iterations on the training data, the X and Y train, to create our neural network model. The training for this takes very little time because each iteration through the dataset is such a small computational task. The dataset isn't very large at all, and it doesn't need to be all that large because what it's classifying is very simple. We can see each iteration takes about, at the very least, 20 milliseconds up to 22 at the most from the example here. And each iteration improves the model by just a small amount, but this is how we train our model.
In our prediction, we included test data to show the model working on predicting between temperature and humidity classes. The model appears to perform well in properly recognizing the correct weather-related word from the given input with high confidence, according to the offered prediction and results. On the other hand, if you look down to the third to last line, it predicted humidity instead of temperature wrongly when the term humidity and temperature was given, and this prediction was made with a lower confidence score. The model appears to be effective at correctly predicting weather-related items from input phrases overall. For the results, The model ability to correctly identify and perform simple tasks such as addition, subtraction, multiplication, and division. We also were successful in training it to provide what its purpose, providing the current time, weather, and able to pull up Dr. Yu's information page as well as music on YouTube. This will be given in the live demonstrations. For the discussion, some of our shortcomings during the project includes to fully understand our model, wake word cooperation. It was difficult to get the wake word to recognize what we are saying. There's a lot of background noises, so it pick up everything from our surroundings. Um, Another shortcoming would be utilizing the YouTube for music instead of a more reliable music platform such as Spotify or Pandora. Um, and then for our project management, we all did the project research between Max, Kevin, and I. Um, Coding, we all did a little bit of coding in their testing. Max and I had the Arduino set up, so we were able to get the test temperature settings and humidity. And then Kevin was in charge of the report organization.
And then for our conclusion, our study had several important implications for the field of speech recognition. Firstly, we demonstrated the importance of engineering in speech recognition. Engineering involves selecting and extracting relevant features from the input data to improve the accuracy of the machine learning model. And our study showed that the use of relevant features significantly improved the accuracy of the speech-to-text system. Secondly, we found that the size and complexity of the machine learning model can significantly impact its accuracy. And then thirdly, our study demonstrated the importance of using sensors to provide additional information about the environment and aid in the speech recognition process. We used a few sensors, including microphones and temperature sensors, just to gather information about the environment, like humidity, and then picking up our voice with the microphone, obviously. And that was for limiting outside noise, because we were struggling when we were trying to work with just like the built-in microphone from our laptop. When everyone was in the class, it would pick up a lot of the background noise. So we found that getting an actual microphone and hooking it up helped improve the accuracy significantly. And then our results showed that the use of sensors significantly improved the accuracy of the system, as I mentioned. Moving forward, there are several avenues for future research in this area, including the use of larger and more diverse data sets, more advanced signal processing techniques, alternative sensors, maybe more than the two sensors that we used, natural language processing, and the application of the system to various domains. We believe that our project and study provides a solid foundation for future research and the development of speech recognition systems, though.
So I have my phone here so you guys can see the temperature and humidity coming from the Arduino that's being fed into the computer right now. So I'll do the demonstration from here. So we can see as a new model gets trained up pretty quickly. And now it should be ready to go after showing us some test results. And you can see it's already classifying, or not classifying, but converting our speech into text. So we can start. Let's see. Dr. Yu.
Yes?
What's the humidity of the room right now?
Sure, the humidity is 47.10%.
Dr. Yu,
Yes?
how about the temperature of the room right now?
Sure, the temperature is 69.26 degrees.
And then we can have it do other things. For example, if we wanted it to multiply or divide or anything like this, we can get it to do that. Dr. Yu,
Yes?
what's 47 times 836?
Sure, 47 times 836 is 39,292.0.
Dr. Yu,
Yes?
can you divide 30 by 0?
Do I sound like a fool to you?
So Dr. Yu doesn't like to answer questions like that. How about Dr. Yu, can you tell me... All right,
Yes?
there we go. Forgot how to use my own thing. Can you tell me about yourself?
I'm a simple voice assistant. I can tell you about the time, the temperature and humidity of your environment, the weather in different areas, and answers to basic math questions. I can also play music from YouTube. I was created by 3 undergraduate students with nothing better to do with their time.
So we can move on to some more stuff here. And maybe we want Dr. Yu to tell us the time. Dr. Yu,
Yes?
can you tell us the time right now?
Sure, the time is 10:58 a.m.
You can see the time down there. And how about this? Dr. Yu, Dr. Yu,
Yes?
play Baby by Justin Bieber.
Sure, 1 second while I play by Justin Bieber.
We don't need any more of that. How about Dr. Yu?
Yes?
Can you show me your website?
Sure, here is my website.
And then we can see Dr. Yu's website. So this will end the code demonstration for time's sake, but thank you for watching.